Good morning, students. For the next 2 or 3 weeks, we're going to go over a concept called momentum. Today, all I need you to do is write down the notes for 7.1. So just follow along, write down what I write down, and you'll be all set for the day. Lesson 7.1 covers an equation called the impulse-momentum theorem. Now, what the impulse-momentum theorem says is that impulse and momentum are two things that are related. But of course, before understanding or using this idea, we need to define both of those things first. So first we're going to define momentum. There are a couple types of momentum, and the one we're going to focus on specifically is something called linear momentum. So momentum in a straight line. Here's a mathematical definition. It's a product. Linear momentum is the product of mass and velocity. So basically, momentum is just the combination of mass and velocity. If something is very heavy, it has a lot of momentum. If something is very fast, it has a lot of momentum as well. Two different examples of that would be a freight train. A freight train is very, very heavy, and although it's slow, since it has so much mass, it has a lot of momentum. A bullet, on the other hand, has very low mass, but since it has high velocity, it also has a high amount of momentum. So here's the equation we're going to use to represent these things. So P is momentum. The little arrow above it just means that it's in a straight line. That means that this number, if it's negative, it means it points left. If this is positive, it means it points right. Or if it's negative, it points down. If it's positive, it points up. So that's all that top arrow means. You could skip that. Same thing for V. So P, like I said, that's linear momentum, or just momentum for short. You can write down either one of those. That's linear momentum, kilogram meters per second. Kind of a weird unit, but that's the unit. Kilograms times meters per second. That's the way to write it. Of course, M is mass, and that's measured in kilograms. V is velocity, and that's measured in meters per second. So that's momentum. P is momentum, M is mass, V is velocity. So that's the first part of the impulse-momentum theorem. We also have to define impulse. Now, impulse is basically a change in momentum, but we're going to define it a little differently. It has two definitions. It's change in momentum, or here's the other definition. Impulse is, again, a mathematical definition. It's another product. It's the product of average force and time of contact. So impulse is when you change something's momentum, if you push it. And to do that, you take the amount of force, the average force that's pushing on that thing, times the time that it's in contact with. So we'll go to the bullet example, I guess. So when a bullet hits a wall, the thing that's changing the momentum of the bullet is the wall. The wall is putting a force on the bullet, and for a very small amount of time. So we would use the amount of force the wall is pushing with times the amount of time that the bullet is in contact with the amount of time that the wall and the bullet are in contact with one another. Here's how we write that equation, though. So for impulse, we're not going to use an I, because I is for something called current. So we're going to use J for impulse, capital J. Again, it's got an arrow above it. That means it's a vector. That means that positive and negative have a meaning for it. Equals F times arrow line. I'll explain these after I read them. Let me read those again. So we have J with an arrow above it. We got F with an arrow and a flat line above it. And we have delta T. So the delta T is just change in time. Delta T are one variable together. F is force. The flat line means average, and the arrow means that positive and negative has meaning for it. The arrow means that if this value is negative, force is pointing left or down. And the arrow also means that if F is positive, the force is pointing right or up in the positive direction. So here's our three definitions for these, I guess. So this is impulse. It has a strange unit, just like momentum. It's the same as momentum, actually. It's kilogram meters per second. F is, it's not just force, it's average force. And that's measured with a capital N, newtons. And then we have a very specific version of time. So this is change in time, or you can call it time. You can write down either of those. I'm going to write down the official aspect of it, the official definition of it. It's the amount of time for which an object is pushed. And of course, that's measured in seconds. I'm going to stop the video here, and we'll do one or two more parts.